Good evening. Good evening, everyone. Am I audible? Now, determinant and properties of determinant. In the previous class, I have discussed about what is determinant. Just I have given only simple example, right? Now, determinant and properties of determinant. For example, if the matrix is 2 cross 2, if the matrix is 2 cross 2, 2, 5, 2, 5, 3, 9. If the matrix is 2 cross 2, 2, 5, 3, 9, then determinant value of A equal to 18 minus 15, 3. Understood? Definitely, Shivam. Now, det A equal to 18 minus 15. Whenever matrix is 2 cross 2, determinant is given by AD minus BC. Now, suppose your matrix is 3 cross 3. Suppose the given matrix is 3 cross 3. 1, 2, 3, 2, 4, 3, 3, 5, 6. For example. Okay. Whenever matrix is 3 cross 3, then whether you can take a row or a column. In the previous class, I have given the definition. The sum of the products of elements of a row or a column, elements of a row or column with their corresponding cofactors is known as determinant value of the matrix. The sum of the products of elements of a row or column with their corresponding cofactors is known as determinant value of the matrix, right? Now, that's why I am taking elements of first row 1 multiplied with its cofactor 24 minus 15, 24 minus 15, minus 2 of, minus 2 of 2 into 6, 12, minus 9, plus 3 of, plus 3 of 10 minus 12. Okay, now 24 minus 15 is 9, minus 2, 12 minus 9 is 3, 3 2 just 6, plus 3 into minus 2, 3 into minus 2, minus 6. So 9 minus 12, that is minus 3. The value of determinant is minus 3. Understood? Next. Suppose the given matrix is 4 cross 4. The given matrix is 4 cross 4. Matrix A is 4 cross 4. 1 0 2 3, 0 3 0 4, 1 minus 1 2 5, 0 0 0 4. For example. Okay, please remember, whenever matrix is 4 cross 4 or 5 cross 5, higher order, always you have to expand determinant with the help of a row or a column consisting of maximum number of zeros. maximum number of zeros. So last row is consisting maximum number of zeros. Understood? Sir, what is the advantage by taking maximum number of a row which consisting maximum number of zeros? You can reduce your calculation work. Okay. Now, because determinant is nothing but the sum of the products of elements of a row with their corresponding cofactors. Suppose if you take element 0, 0 multiplied with corresponding cofactor becomes 0. That's why select a row which consisting maximum number of zeros. Okay. Now, last row, 3 zeros and 1 non-zero element. Fourth row, fourth column, that is the non-zero element. So 4, sir, plus 4 or minus 4. The sign of cofactor is decided by its position. Okay. 4 is in which row and which column? Fourth row and fourth column. Minus 1 whole power I plus j means 4 plus 4. Minus 1 whole power 4 plus 4 is plus. That's why I have taken plus 4. Catch my point? Multiplied with eliminating fourth row and fourth column, you have 1 0 2 0 3 0 1 minus 1 2. Understood? Now 4 of 1 multiplied with 6 minus 0 minus 2 minus 0 plus 2 of 0 minus 3. Understood? Continuation. 4 multiplied with 6 minus 6. Finally 0. The value of determinant is here 0. Understood? So select a row, multiply with corresponding cofactors. While selecting a row, always the suggestion is whenever matrix is of higher order, select a row which consisting maximum number of zeros. Okay. If 0 is present, 0 into its cofactor is 0 now. Huh? Next. If 0 is not there, what you have to do? I am explaining. Wait. For example, matrix is 4 cross 4. Matrix is 4 cross 4. 1 plus x, 2, 3, 4. 1, 2 plus x, 3, 4. 1, 2, 3 plus x, 4. 1, 2, 3, 4 plus x. No entry is 0. If no entry is 0, what we have to do? Apply suitable elementary operations and reduce some entries of any row or any column as 0. Okay. Now I am applying the operation C1 plus C2 plus C3 plus C4. By applying C1 plus C2 plus C3 plus C4, first column 10 plus x, 10 plus x, 10 plus x, 10 plus x, 2, 3, 4, 2 plus x, 3, 4, 2, 3 plus x, 4, 2, 3, 4 plus x. Okay. Next, apply the operation R2 minus R1, R3 minus R1, R4 minus R1. By applying R2 minus R1, R3 minus R1, R4 minus R1, we get 10 plus x, 2, 3, 4. Now, R2 minus R1, 10 plus x minus 10 plus x, 0. 2 plus x minus 2, x. 3 minus 3, 0. 4 minus 4, 0. 10 plus x, minus 10 plus x, 0. 2 minus 2, 0. 3 plus x minus 3, x. 4 minus 4, 0. 10 plus x minus 10 plus x, 0. 2 minus 2, 0. 3 minus 3, 0. 4 plus x minus 4, x. Now, I am going to expand determinant with the help of first column. Now, 10 plus x multiplied with x0, 0, 0x0, 0x. That is 10 plus x into x cube. I have not taken any term common. You can take common, no problem. That is one approach. This is another approach. Okay. You can take fourth row, Raghav. Sir, in the previous problem, you have taken fourth row. Here also, you have to take fourth row. You can take any row or any column. Understood? In first column also, you have maximum number of zeros. Not only fourth row. Okay. Raju, if you want to write, you can write 10 plus x into, by taking x of x square minus 0. Okay. That's why you got this step. You can apply elementary operations either row wise or column wise. Any rule is applicable for rows. The rule is applicable for columns also. Okay. Sir, you have taken C1 plus C2 plus C3 plus C4. I would like to apply R1 plus R2 plus R3 plus R4. No problem, you can apply. 10 plus x kaise kiya na? I have not taken common, man. I have not taken common. Just I have expanded by using first column. 10 plus x into, by deleting its row and its column. I got this 3 cross 3 determinant. Don't misunderstand the concept. I have not taken common. Just I have expanded determinant by first column. Okay, next. So simple. Whenever matrix is 2 cross 2, AD minus BC technique. Siddharth, I already told you, you can take column wise or row wise. I have added columns. If you would like to add rows, you can add rows. 10 plus x kaise. Huh? 1 plus x plus 2 plus 3 plus 4 is kitna? 10 plus x na? 4 plus 3, 7, 7 plus 2, 9, 9 plus 1 plus x, 10 plus x. I have added this, I have applied this operation in which column? First column. Okay. Now, simple. If the matrix is 2 cross 2, apply AD minus BC. 3 cross 3, select a row multiplied with corresponding cofactors. If it is 4 cross 4, select a row which consisting maximum number of zeros. Okay. Suppose zeros are not available, apply operations and reduce some entries as zeros. Okay. Next, properties of determinants. Properties of determinants. Determinant value of A and determinant value of A transpose are always same, because I already told you You can take any row. Choice is yours. I have taken first column. If you would like to take last row, you can take. Now, determinant value of A and determinant value of A transpose are always same. Determinant value of AB, determinant value of AB equal to det A into det B. Determinant value of AB equal to det A into det B. Determinant value of A plus B not necessarily equal to det A plus det B. Determinant value of A plus B not necessarily equal to det A plus det B. Determinant value of A plus B is not necessarily equal to det A plus det B. Please remember, determinant value of AB equal to det A into det B, but determinant value of A plus B not necessarily equal to det A plus det B. May or may not. Abhishek, some students may question, sir, one matrix is null matrix. If one matrix is null matrix, then equality is possible. But, okay, in general, determinant value of A plus B not equal to det A plus det B. That's why not necessarily. Now, in a matrix, in a square matrix, because determinant exists only when matrix is square, na? Priya, this is my third lecture. Okay? If you want to join next batch, you have to wait for 2 months. Now, in a square matrix, Muhammad, I will explain. I have one sequence. Okay? You have to wait till that time. First, let me explain. You need not to verify anything. I will explain each and every point. Okay? But some sequence is required. Otherwise, students get confused. Okay? Now, in a square matrix, if each element of a row, any property is applicable for row, that is applicable for column also. Okay? Now, in a square matrix, if each element of a row or column is 0, then the value of X determinant is 0. In a square matrix, if each element of a row or column is 0, then the value of determinant is 0. Okay? For example, 2, 3, 5. 7, 8, 9, 0, 0, 0. Suppose if you expand determinant by last row, then what is determinant value? 0. So det A is 0. Or if you expand by first row, then also determinant value is 0. But last row is completely 0 row na? 0 into its cofactor is always 0. That's why determinant value is 0. Next. पीयूष थोड़ा सोचना पड़ेगा आपने. रेक्टेंगुलर मैट्रिक्स को डिटरमिनेंट आएगा क्या? I have mentioned in a square matrix. You are asking, sir, rectangular matrix. Next, in a square matrix, if two rows within bracket columns, any property is applicable rows, it is applicable for columns also. Okay. Now, if two rows or two columns are in a square matrix, if two rows or two columns are identical or proportional, then the value of 8's determinant is 0. The value of its determinant is 0. For example, 1, 2, 5, 2, 3, 6, 4, 6, 12. Okay. Now, Mohammed, I already told you, I will teach you operations when it is required. This is second time I am informing you. We have one sequence, I am following that sequence. Now, determinant value of A is 1 of 36 minus 36, minus 2 of 24 minus 24, plus 5 of 12 minus 12. Finally, the value is 0. Okay. Since R2 and R3 are proportional, these two rows are proportional. So if two rows or two columns of a matrix are proportional, then the value of its determinant is 0. Next. The determinant value of a triangular or diagonal. The determinant value of a triangular or diagonal matrix. The determinant value of a triangular matrix or a diagonal matrix is the product of its leading diagonal elements. The product of its leading diagonal elements. For example, matrix A 2, 3, 5, 0, 4, 6, 0, 0, 8. It is a triangular matrix. All the elements below the principal diagonal are 0. Okay. Now, det A equal to 2 of 32 minus 0, minus 3 of 0 minus 0, plus 5 of 0 minus 0. Therefore, determinant value is 64. 64 is nothing but product of its leading diagonal elements, 2 into 4 into 8. Understand? What is diagonal matrix? I have explained in the first lecture. You watch the recorded video. Next. If A is A, if A is a square matrix, here I am not talking about trace. I am talking about only product of its leading diagonal elements. Product of leading diagonal elements is different, trace is different. Don't merge the concept. Okay? Trace is sum of leading diagonal elements. I am not talking about trace. I am talking about only product of leading diagonal elements. Here I have mentioned clearly product of leading diagonal elements. If A is, 1 minute, Ahmad, whenever you are asking a question, first you think first. Is trace exists for non-square matrix? Is principal diagonal exists for non-square matrix? Huh? No. Then how you can get principal diagonal? How you can get your trace? Suppose your goal is to disturb the class, better to leave the class. Learn the subject properly. If you have any innovative thoughts, you can ask me later at the end of the class. Okay? If A is a square matrix, if A is a square matrix of order m, if A is a square matrix of order m and K is any scalar, if A is a square matrix of order m and K is any scalar, then determinant value of Ka equal to K power n into det A. So here, suppose A is a 2 cross 2 matrix. I am not taking n cross n. Just by 2 cross 2 I am explaining. A11, A12, A21, A22. Here Ka, Ka11, Ka12, Ka21, Ka22. Right? Now, determinant value of Ka equal to determinant value of Ka11, Ka12, Ka21, Ka22. You take K common from determinant. If you would like to take an element common from determinant, you have to take it common from each row. So you can take 1k from first row, 1k common from second row. K into k square. A11, A12, A21, A22. That is k square into det A. Since our matrix is 2 cross 2, that's why you got k square into det A. Suppose your matrix is n cross n, then k power n into det A. Because you have n rows, you can take k n times, you have to take common, because first row 1k, second row 1k, third row 1k. That's why k power n multiplied with det A. Understood? Next. The determinant value of skew symmetric matrix of odd order. The determinant value of skew symmetric matrix of odd order is always 0. The determinant value of skew symmetric matrix of odd order is always 0. Okay, observe here. What is skew symmetric matrix of odd order? What is odd order? Odd order means 3, 5, 7, like that. 1 is odd number, but don't take 1 cross 1. If you take 1 cross 1, you will get non-zero entry. How it will become 0? If your matrix is 1 cross 1, you can't prove that skew symmetric. You have to take 0 entry. Okay? That's why start from 3 cross 3. You start from 3 cross 3, right? Okay. The determinant value of skew symmetric matrix of odd order is always 0. Let us take matrix A 3 cross 3. I already told you, principal diagonal elements of skew symmetric matrix are always 0, right? 0, 0, 0. Remaining entries, you have to satisfy one condition. Aij equal to minus Aji. So if you take minus 1, you have to take plus 1. It is minus 2, you have to take plus 2. If it is 3, you have to take minus 3. Understand? Clearly, Aij equal to minus Aji for all ij. Now, det A 0 plus 1 of 0 minus 6 minus 2 of minus 3 minus 0. That is 0 minus 6 plus 6, which is 0. Okay? Det A equal to 0. Next. The determinant value of an orthogonal matrix Raju, I have given the property for odd order. Means odd order is always 0. Suppose if for even order also, if it is 0, I would mention na? The determinant value of skew symmetric matrix is 0, I can give na? Here for even order, the property is not generalized. Okay, that's why you should not take even order. I have mentioned odd order, you have to take odd order. Okay, now when it is required, I'll give the proof. Right, the determinant value of an orthogonal matrix is, the determinant value of an orthogonal matrix is always either 1 or -1. Either 1 or -1. Okay, either 1 or -1. I would like to prove this property with the help of definition of orthogonal matrix. When we say matrix is orthogonal matrix, I am talking about definition, not properties. I am talking about definition. What is definition of orthogonal matrix? A into A transpose equal to I. Okay. Now observe. A into A transpose equal to I. Because the matrix is orthogonal matrix. 1 minute. Please understand. A is a matrix. A into A transpose equal to I. Okay. Orthogonal matrix is collection of orthonormal vectors. When you take vectors, you can write R1 transpose dot to R2 is 0. But don't write A into A transpose 0. That is absolutely wrong. Okay. A into A transpose is I. Okay. A into A transpose is I. I am not talking about vectors here. I am talking about matrix. Right. I have to prove that. Please consider. I have to prove that determinant value of orthogonal matrix is always either 1 or -1. That's why I am taking determinant on both sides. Determinant value of A into A transpose equal to determinant value of I. Okay. Now det A into det A transpose equal to 1. Understood? Because determinant value of AB equal to det A into det B. Therefore, A into A transpose equal to I. I have taken determinant on both sides. Determinant value of A into A transpose equal to determinant value of I. So det A into det A transpose equal to 1. Now, please observe. Determinant value of A transpose and determinant value of A are always same. That's why det A into det A equal to 1. A and A transpose are not same. Determinant value of A and determinant value of A transpose are same. Now det A into det A is det A whole square equal to 1. Therefore det A is plus or minus 1. The determinant value of an orthogonal matrix is either 1 or -1. Understood? If your matrix is orthogonal matrix, determinant value is 100% either 1 or -1. सर आपने प्रीवियस क्लास में एक प्रॉब्लम लिया, वो प्रॉब्लम में डिटरमिनेंट अभी चेक करना. You can verify. You have 24 hours time. You verify. If determinant value is not 1 or -1, then you can post the question tomorrow. Okay? Now, Sachin, if det A is -1, if you take square is a positive number or not? 100% positive number, na? Okay. Determinant value of an orthogonal matrix is either 1 or -1. Fourth step, very simple. Determinant value of A transpose equal to determinant value of A. Okay. Determinant value of A and determinant value of A transpose are same. Okay, next property. If A is a non-singular, sir, what is non-singular? Determinant is non-zero, then it is called non-singular. If A is a non-singular matrix, of order n, then first property, A into adjoint A equal to det A into I. A into adjoint A equal to det A into I. A into adjoint A equal to det A into I. Next, determinant value of adjoint A equal to det A whole power n minus 1. Determinant value of adjoint A equal to det A whole power n minus 1. Third one, determinant value of adjoint A equal to det A whole power n minus 1 whole square. Determinant value of adjoint A is det A whole power n minus 1 whole square. Please observe third property and fourth property. There is a difference between third property and fourth property. Adjoint A equal to det A whole power n minus 2 into A. Det A whole power n minus 2 into A. Observe third and fourth, both are different. Third property is determinant of adjoint A. Fourth property is matrix. Adjoint A equal to det A whole power n minus 2 into A. Nitya, I am coming to that point only. Wait for 2-3 minutes. This is matrix. This is determinant. Matrix is different, determinant is different. Okay? Now, adjoint A is det A whole power n minus 2 into A. Determinant of adjoint A is det A whole power n minus 1 whole square. Understood? Next, fifth one, A inverse equal to adjoint A by det A. Sixth one, Sachin, I am coming to that point only. Let me give 6 properties. After that, I will explain what is adjoint A, how to write adjoint A. Okay? Yes, Ria. Adjoint A means det A whole power n minus 1 whole cube. Suppose you have 4 times, whole power 4 will come. Okay? Now, sixth property, determinant value of A inverse equal to 1 by det A. A inverse equal to adjoint A by det A. Determinant value of A inverse equal to 1 by det A. Now I would like to explain what is adjoint of A, how to write adjoint of A. Suppose matrix A is A, B, C, D. Suppose. Okay. Now, what is adjoint of A? To write adjoint of A, first you have to write cofactor matrix. Cofactor matrix. What is cofactor matrix? Wait. Every element of A replacing by its corresponding cofactor. Every element of A replaced by its corresponding cofactor. Then you will get cofactor matrix. Tell me, what is cofactor of A? Eliminate its row and its column multiplied with -1 whole power I plus j. Okay. Now D is cofactor of A. What about cofactor of B? Cofactor of B, eliminate its row and its column. Sir, you have C. Shall I write C or minus C? C or minus C? Minus C. Because it is first row, second column. -1 whole power 1 plus 2 is -1. That's why minus C. Okay. Next. Cofactor of C. Cofactor of C minus B. Minus B. Because second row, first column. 2 plus 1 odd number. That's why minus B. Now cofactor of D. A. That is cofactor matrix. Now adjoint of A is transpose of cofactor matrix. If you transpose cofactor matrix, you will get D minus B minus C A. That is adjoint of A. Understood? What is determinant value of A? Determinant value of A, AD minus BC. Now, A inverse equal to adjoint A by det A. 1 by AD minus BC of D minus B minus CA. That is A inverse. Next. Suppose your matrix is 3 cross 3. Darshini, that is called innovative thought. I already told you don't take 1 cross 1. Always you have to start from 2 cross 2 onwards. Okay. Now, previous slide. No doubt. Back slide, nothing. Formula. This is example. Completed? Next. Observe. Suppose your matrix is 3 cross 3. Suppose your matrix is 3 cross 3. -1, 2, 2, 2, -1, 2, 2, 2, -1. For example, -1, 2, 2, 2, -1, 2, 2, 2, -1. You have 9 elements. 9 elements. Suppose if the matrix is with 9 entries, you have to find 9 cofactors. 9 cofactors. After that, cofactor matrix. Transpose of cofactor matrix gives us adjoint of A. Okay. Now, I would like to give one trick to find adjoint of A directly, but the trick is applicable only for 3 cross 3. Concentrate here. While I am explaining, observe. The problem is, after completion of the method, if you ask me explain once, it is difficult to explain. Again, I have to take another slide. That is the problem. Concentrate. Next, you can copy. If your matrix is 3 cross 3, middle, last, first, middle. From middle column, middle element. This is middle column, this is last column, this is first column. Okay. Now, from middle column, middle element, write the entries clockwise. Concentrate here. Concentrate here. -1, 2, 2. Clockwise. Next, last column. Last column. Again, same process. Means from middle element, write the entries clockwise. 2, -1, 2. Next, first column. First column. Again, middle element. From middle element. From middle element. Write the entries clockwise. 2, 2, -1. 2, 2, -1. Again middle. Again middle column, middle element. Write the entries clockwise. -1, 2, 2. Do you understand? It is not adjoint of A. With the help of this, we are going to find adjoint of A. Okay? Observe. Observe. Repeat. Repeat this first column once again here. First column means this one. This one. -1, 2, 2, -1. Understood? Understood? Now what we have to do? Adjoint of A is given by, adjoint of A is given by, directly you can get adjoint A with the help of this arrangement. Observe. Concentrate here. Just you have to apply AD minus BC technique. Observe. -1 into -1, 1, -2 into 2, 4. 1 - 4, -3. Next, this product, 2 2 ja 4, 4, minus of -2, 6. Next, 2 2 ja 4, minus of -2, 6. Understood? Next, this product, 4 plus 2, 6. -1 into -1, 1, 1, -4, -3. 2 2 ja 4, plus 2, 6. Next, 4 plus 2, 6. 4 plus 2, 6. 1 - 4, -3. This technique is applicable for any 3 cross 3 matrix, any 3 cross 3 matrix, any 3 cross 3 matrix. Understood? कैसा लिखना है अभी तक मैंने एक्सप्लेन किया आपको. Understood? But the technique is applicable only for 3 cross 3 to calculate adjoint of A. You note down in your notes. Deepali Singh, fourth column is repetition of first column. Fourth column is repetition of first column. I said middle column, middle element, you have to follow if you would like to get the answer. I said always, not for this problem. One problem, one method, दूसरा problem के लिए दूसरा method. The trick is applicable for any 3 cross 3 matrix, right? Understood? Now, yesterday we have covered the problems. Saurabh, you can watch the recorded video even 10 times. Okay? No problem. Come to the problems. I have completed this problem, right? We got 5 factorial. Okay? Next, observe. It is with reference to conventional Cartesian coordinate system, the vertices of the triangle have the following coordinates. Then the area of the triangle is, it is a method which is application of determinant. With the help of determinant, you can calculate area of the triangle with 3 vertices x1, y1, x2, y2, x3, y3. Okay? Now, observe. There is a formula to calculate area of the triangle. Area of the triangle with the help of determinant. Chandani, I have explained the procedure of previous problem in the previous lecture. Okay, I said I have completed this problem in the previous lecture. We got the answer, this one. So if you want to detailed solution, you watch the previous class, last lecture. Okay, now Prajwal, till now ESC examinations we got only 4 question papers, 4 15s. Okay, 60 questions, overall 10 chapters. So for one chapter on and average 6 questions, we are solving 120. Now observe. Area of the triangle. Area of the triangle is given by half into determinant of 1 x1 y1 1 x2 y2 1 x3 y3. Actually we have to write plus or minus 1 by 2. Plus or minus 1 by 2. Sir, why you have taken plus or minus 1 by 2? Suppose if your determinant value is minus of some real number, you have to take minus 1 by 2. If the determinant value is positive, you have to take plus 1 by 2. Understood? That's why plus or minus 1 by 2 into determinant of 1 x1 y1 1 x2 y2 1 x3 y3. This is the procedure. Okay? Now plus or minus 1 by 2 of 1 1 1. We cannot put mod outside, man. Mod will be inside only. 102243. 1 0 2 2 4 3 plus or minus 1 by 2 of 1 multiplied with 6 minus 8 minus 1 of 3 minus 2 plus 0, right? That is plus or minus 1 by 2 of 6 minus 8 is 2 minus 1, that is minus 1 by 2 of minus 3, that is 3 by 2. Area is 3 by 2. Understood? Since area is positive, that's why we have to write plus or minus 1 by 2 outside. According to the requirement, you have to take either plus 1 by 2 or minus 1 by 2. Okay? Right. Next problem. It is determinant value of A. Determinant value of A is 6. A is 3 cross 3 matrix. Then, Ravi, I have explained you the procedure. I have given the formula. Okay? This formula is generated by vectors concept, vector algebra concept. Why you have taken 1 1 1? That proof is not required. When it is required, definitely I'll give the explanation. Determinant value of A is 6. Matrix is 3 cross 3. Then determinant value of 2A whole inverse is 2A whole inverse. Here we have two properties. One property is determinant value of A inverse equal to 1 by det A. Another property is determinant value of Ka equal to K power n into det A. Both the properties I have given. In this problem, we have to apply these two properties. First, given that det A is 6, determinant value of 2A whole inverse is nothing but, by using this property, you can write 1 by determinant value of 2A. Next, by using this property, you can write 1 by determinant value of Ka is K power n into det A. Sir, what is n? N is order of the matrix. Order of the matrix is 3 cross 3. That's why 2 power 3 into det A. Since A is 3 cross 3. Now 1 by 2 cube is 8. Det A is 6. 1 by 48. So the answer is 1 by 48. Understood? Next problem. Let A be n cross n matrix with entries 0 and 1. N greater than 1. N greater than 1 means you should not take 1 cross 1 matrix. You have to start from 2 cross 2 onwards. That is the meaning. If there is exactly one entry in each row and each column of A, in each row and each column of A, then the determinant value of A must be. Then what is the determinant value of A? Okay. Observe here. You need not to take n cross n matrix. You need not to take n cross n matrix. By examining 2 cross 2 or 3 cross 3, you can get the answer. You should not take 2 cross 3, Mr. Pathak. Determinant value does not exist for non-square matrix. Okay? Determinant exists only when matrix is square. Okay, now come here. Suppose if you take 2 cross 2 matrix, 1 0 0 1, okay, or you can generate 0 1 1 0. Exactly one non-zero entry. What is your non-zero entry? One only. Okay, so in each row and each column of A, every row consisting only one non-zero entry, each column consisting only one non-zero entry. That's why either you can generate 1001 or 0110. So here determinant value is 1. Here determinant value is -1. Therefore, for n cross n matrix also, either 1 is possible or -1 is possible. Okay, that's why correct answer is either 1 or -1. Neha, last year I have given daily practice problems, daily 5, total 640 questions I have covered. This year, what I have done, all 640 DPPs together, I have published in one book. That book I have posted in the Telegram group as well as WhatsApp group. You collect the book. Okay? What I am doing, I am solving those 640 problems in the practice course with serial number, one by one. What you have to do after completion of first chapter, you solve all problems of that book, DPP's book, first chapter. You finish first chapter. Definitely you will get the answers. Whether your answer is right or wrong, you can cross verify with my practice course solutions. Okay? In that way, you have to build the practice. WhatsApp group link, everything I'll give you at 11:30. First, concentrate on the content. Yes, Avdesh. Now, come to the problem. Next problem. Let A be a 10 cross 10 matrix in which each row has exactly one entry is 1. Exactly one entry is 1. Exactly one entry is 1. The remaining 9 entries of the row being 0. Then which of the following is not possible value of determinant? I am explaining. Sir, what is the difference between previous problem and present one? In the previous problem, exactly one non-zero entry in each row and each column. Here, one entry is 1, the remaining 9 entries of the row being 0. Here there is no condition for column. Here condition is only for rows. There not only rows but also column. Here only for rows. That's why you can arrange like this. If you take 2 cross 2, you can arrange 1 0 0 1, 0 1 1 0, 1 0 1 0. In this case, determinant value is 1. In this case, determinant value is -1. In this case, determinant value is 0. आदित्य, skew symmetric कैसा होता जी? हमारा पास only 1 and 0 are the entries ना? How can you develop a skew symmetry? You can develop one null matrix, but null matrix is not satisfying that condition. That's why either 1001 form or 0110 form or 1010 form. Here determinant is 0, here determinant is -1, here determinant is 1. Okay. 10 is not possible. 10 is not at all possible. Why? Because for 2 cross 2 determinant is not 2. For a 2 cross 2 matrix determinant is not 2. How it will become 10 for 10 cross 10? That's why understood? Here the condition is not for columns. The condition is only for rows. Not any entry, either 0 or 1. You have to use only either 0 or 1. Not anything. Observe next column. Observe the problem. Try this one. Number of terms means unsimplified form. Okay, I am giving one hint. Number of terms means if you simplify, determinant gives only one value. That is not the question. You have to understand this. The number of terms in the expansion of general determinant of order n. Unsimplified form. If you take numbers, you can't get the answer. If you take some variables, you can get the answer easily. Observe here. You need not to take 10 cross 10 or n cross n. Just you take simple 2 cross 2 and 3 cross 3. You can get the answer very easily. Suppose if you take a 2 cross 2 matrix, don't take numbers. Generally, if you take numbers, we are tempted to do simplification. Suppose 4, 3, 6, 8. What you will do? 8 4 is 32, 32 minus 18. You will get one number. That is not the process. You have to write determinant in unsimplified form. That's why let us take A, B, C, D. A, B, C, D. What is determinant? AD minus BC. AD is one term, BC is one term. How many terms? Two terms. Understood? Suppose if you take 3 cross 3 determinant, 3 cross 3 determinant, A, B, C, X, Y, Z, P, Q, R. Now, A of YR minus QZ minus B of XR minus PZ plus C of XQ minus PY. Now, 1, 2, 3, 4, 5, 6. How many terms? 6 terms. So in the case of 2 cross 2, 2 terms. In the case of 3 cross 3, 6 terms. 6 terms is nothing but 3 factorial. 2 terms is nothing but 2 factorial. In the case of 2 cross 2, 2 factorial. In the case of 3 cross 3, 3 factorial. Therefore, in the case of n cross n, it would be n factorial. So n factorial is the answer. Observe. Try this one. Observe here. It is a problem designed on properties of determinant. Which one of the following does not equal to 1x square, 1y square, 1z square? Just I am going to use the properties. Let us take first option. 1, 1, 1. X into x plus 1 means x square plus x, y square plus y, z square plus z. X plus 1, y plus 1, z plus 1. Observe here. This determinant can be written as, sum of 1, 1, 1 x square plus x, y square plus y, z square plus z. I have written first column and second column as it is. Okay, 1 1 1, x square plus x, y square plus y, z square plus z. Now split third column into two parts like this: x y z 1 1 1. It is a property. Okay, now in the second part, first column and last column are identical. When two columns are identical, the value of determinant is 0. This determinant is 0. Now observe carefully. This determinant can be further splitted into two parts like this: first column as it is, third column as it is. First column as it is, third column as it is. What I am going to divide, I am going to split second column into two parts: x y z, x square y square z square. Now again second part, in the second part, xyz, two columns are identical, therefore determinant is 0. Now first part is left, so first part can be written as 1 1 1, x square y square z square xyz. Understood? Second part becomes 0. Now our original determinant is 1 1 1, here 1 1 1, here xyz, x square y square z square, but here x square y square z square xyz. So whenever two columns are interchanged, you have to multiply with -1. That's why -1 into 1 1 1 xyz, x square y square z square. This is not equal to the original determinant, because original determinant, in the original determinant you have here plus sign, here we have minus sign. Because of that minus sign, this is not equal to the determinant 1 1 1 xyz, x square y square z square. That's why first option is correct. Luckily answer is given in the first option. That's why in verification we got the answer first one. Suppose your answer is last option, then you have to try all three options. Understood? Aniket, it is a property, Baba. Whenever two columns are interchanged, you have to multiply with -1. Equal hai to you have to go for second option. Second option equal hai to you have to go for third option. Question wali slide. Note down. Yes, actually Nitin, whenever this type of problem is given, the best method is substituting suitable values in the place of x, y, z. Kaise sir, let us take three values in the place of x, y, z. X equal to 1, y equal to 2, z equal to 3, like that. You verify. If you have numericals, you can calculate determinant value easily. Completed. Next. Mr. Akhtar, after completion of the class, you can download the PDF. Okay? Next, consider J6 equal to 0, 6 cross 6 matrix. Next, first read the problem, which is obtained by reversing the order of the columns of identity matrix I6. Then let I6 plus alpha J6, where alpha is non-negative real number, then the number of alpha, actually not number, the value of alpha, the value of alpha for which determinant value of p equal to 0. Nitin, if you look at the matrix, you can understand how they have reversing identity matrix. Principal diagonal is reversed as dummy diagonal just by observation. Okay. Now for which value of alpha, I6 plus alpha J6, the matrix P I6 plus alpha J6 would become 0. Whether 1 or minus 1, we have to decide. Okay. Now observe. This is J6. This is J6. You alpha J6 matlab kya? You have to multiply J6 with alpha, na? If you multiply J6 with alpha, what will come? In the place of 1 1 1 1 become alpha 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 alpha. That is alpha J6. Okay, na? Now you have to add with I6. If you add with I6, what happened? What happened? Here 1, I mean in the principal diagonal, you will get 1 1 1 1 1 1. Okay. So now your matrix P equal to alpha I plus I6 plus alpha J6 equal to, you will get 1 0 0 0 0 alpha, 0 1 0 0 alpha 0, 0 0 1 alpha 0 0, 0 0 alpha 1 0 0, 0 alpha 0 0 1 0, alpha 0 0 0 0 1. Now observe, determinant value of p equal to 0. It is not my assumption, they have given. So determinant value of p equal to 0. In which case determinant value of p equal to 0? In which case determinant value of p equal to 0? If two rows are identical, determinant is 0, na? Huh? Suppose first row and last row are identical, then determinant value 0 or not? Therefore alpha value must be 1. Right? If two rows are identical, determinant value is 0. Understood? Alpha is non-negative matlab, how it will be minus 1? Next problem. Concentrate. Similar problem we have. The determinant value of the determinant value of a 6 cross 6 matrix, a 6 cross 6 matrix two zero 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 one 020010 002 how many columns we got? 7. Sorry, 4 5 6. Now 001200 0001 0020 10002. You got 7 columns. Total 6 columns, right? I have given 6 columns and 6 rows. Now, what is the value of determinant? We have to find out. What is the value of determinant? So here, matrix is 6 cross 6. We have to find out the value of determinant. That's why I am going to apply the operations. R4 minus 1 by 2 of R3, R5 minus 1 by 2 of R2, R6 minus 1 by 2 of R1. These are the operations I am going to apply in R4, R5 and R6. Okay. Now, first row, there is no operation. I am writing as it is. 200001 020010 002100. Okay. First, let me explain, man. In one day, you won't get all the things. सर हमको कैसा पता चलेगा? 1-2 घंटे में कैसा पता चलेगा? You have to practice. Okay. Now, R4, 4th row minus 1 by 2 of R3. 4th row minus 1 by 2 of R3. Observe, 0 minus 1 by 2 into 0. 0. Next. At a time I am applying only one operation, man. I have written 3 operations because it is going on in 4th row, it is going on in 5th row, it is going on in 6th row. Okay, it means I am applying only one operation at a time. I am not applying 10 operations at a time. 4th row, how many operations I am applying? Only one operation. 5th row, one operation. 6th row, one operation. Always you have to apply operation on previous matrix, not new one. Result you have to write on new one. Okay. Now, 4th row, this is 4th row, this is 3rd row. 0 minus 1 by 2 into 0, 0. 0 minus 1 by 2 into 0, 0. 1 minus 1 by 2 into 2, 1 minus 1, 0. Next, 2 minus 1 by 2, 2 minus 1 by 2 is 3 by 2. Next, 0, 0. Next, fifth row, I am applying this operation. R5 minus 1 by 2 of R2, R1 no operation, R2 no operation, R3 no operation, R4. I have already written that operation. Now R5. Now fifth row, 0 minus 1 by 2 into 0, 0. 1, 1 minus 1, 0. Next, 0 minus 0, 0. 0 minus 1 by 2 into 0, 0. 2 minus 1 by 2 into 1, 2 minus 1 by 2, 3 by 2. Next, 0 minus 0, 0. Next, R6, sixth row, I am talking about this operation. Sixth row, minus 1 by 2 into first row. 1 minus 1 by 2 into 2, 1 minus 1, 0. 0 minus 1 by 2 into 0, 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 0. 2 minus 1 by 2 into 1, 3 by 2. Now you got a triangular matrix. All the elements below the principal diagonal elements are 0. That's why we have one property. The determinant value of a triangular matrix is product of its leading diagonal elements. That's why you multiply 2, 2, 2, 3 by 2, 3 by 2, 3 by 2. After cancellation, you got 27. So final answer is 27. Vineet, first row and last row are proportional. Kaisa ji? How proportional? Here proportional. Here proportional because determinant is 0. Here not proportional. Similar problem. That's why I have discussed here. In the previous question, they have provided that determinant is 0. If determinant is 0, what is the value of alpha? Here, it is looking like previous problem, but you have to calculate determinant value. Understood? Det matlab determinant. DET, determinant. Next, observe this problem. M power 4 is I, where I denotes identity matrix. M is not I, M square is not I, M cube is not I. Then for any natural number k, M inverse equal to, for any natural number k, M inverse equal to, Mr. Akhtar, please understand previous problem. Nothing is proportional in the previous problem. Nothing is proportional. Either 2 hai, here we have 2 and here we have 1. Here we have 1, here we have 2. They are not proportional. Please understand. Now come to the problem. M power 4 is identity matrix. M is not identity matrix. M square is not identity matrix. M cube is not identity matrix. Then the for any natural number k, M inverse equal to alpha problems are a proportional. That's why alpha value 1. That is over. Observe here. M power 4 is I. If M power 4 is I, M is not I, M square is not I, M cube is not I. For any natural number k, M power minus 1 is. Okay. Observe. If M power 4 is I, can you tell me M power 8? M power 8? I only. Because M power 4 whole square, M power 8 equal to I square. I square is always I na? Because identity matrix, whenever you multiply 100 times, you will get identity matrix only. So M power 4 is I, M power 8 is I, M power 12 is I, M power 4k. Is it okay? Just I have raised power k on both sides. M power 4k equal to I. Sorry, if M power 4k equal to I, M power 4 whole power k plus 1 equal to I power k plus 1. If M power 4 power k plus 1 is nothing but M power 4k plus 4 equal to I power k plus 1. That is I. Catch my point? Now I require M inverse. That's why I am going to multiply this equation on both sides with M inverse. Okay. Now M power 4k plus 4 minus 1 equal to I into M inverse. Okay. Now M power 4k plus 4 minus 1 equal to M inverse. M power 4k plus 4 minus 1 is nothing but M power 4k plus 3 na? Understood? Therefore, correct answer is M power 4k plus 3. First, I have tried with M power 4k. I found that M power 4k minus 1 equal to M inverse. But M power 4k minus 1 is not available in the option. That's why I came to know that, okay, instead of power k, we have to take power k plus 1. Catch my point? This is one approach, first method. Second method is sir, M power 4 is I, M power 8 is I, M power 12 is I, M power 16 is I. Multiply with M inverse. M power 8 into M inverse is I into M inverse. M power 12 into M inverse is I into M inverse. M power 16 into M inverse is I into M inverse, like that. Therefore, M power 7 equal to M inverse, M power 11 equal to M inverse, M power 15 equal to M inverse. Therefore, M inverse equal to M power 7, M power 11, M power 15, M power what? We have to find out. If you understand the pattern, 7, 11, 15 and so on, you can estimate m power which one. 7, 11, 15 are in arithmetic progression. Very good. 7, 11, 15. These are all in arithmetic progression. Here, in arithmetic progression, A is first term, 7. Common difference is D, 11 minus 7, 4. So, nth term is A power n minus 1 into D, or A power k minus 1 into D. 7 power k minus 1 into 4. That is 7 plus 4k minus 4. That is 4k plus 3. So m power 4k plus 3 is the correct option. That is another approach. Understood? Next. Observe this problem. Previous slide. Okay. Because I will explain you in the last 5 minutes. Okay, let me finish. I will explain you the approach also. Why you have to follow that approach also I will explain. If X and Y are two singular matrices such that XY equal to Y, YX equal to X. Sir, what is the meaning of singular matrices? Sir, why they have given singular matrices? Singular matrix means determinant is 0. Determinant of X is 0. Determinant of Y is 0. Sir, why they have given singular matrices? They have given singular matrices because generally to solve this problem, whenever there is xy equal to y or yx equal to x, such type of relations are given, we have one mathematical practice. We use it to multiply with the m inverse or x inverse or y inverse on both sides. Okay, that's why they have given that hint. Why they have given singular matrices? The singular matrices are mod determinant value of x is 0, determinant value of y is 0, means x inverse and y inverse does not exist. Suppose in your thought, if you get to apply x inverse, y inverse, you should not go in that direction. He is cautionous. Okay, don't touch x inverse and y inverse to solve this problem. You have to solve this problem with the given conditions. Sir, what are the given conditions? Xy equal to y and yx equal to x. Okay. Xy equal to y and yx equal to x are the hints to solve the problem. What is your problem? X square plus y square is which of the following? Concentrate here. X square plus y square. X square is nothing but x into x. Y square is nothing but y into y. We all know. Now, what we have to do, whatever hints they have provided in the data, what is the hint? Xy equal to y and yx equal to x. Sir, how yx equal to x? They have given, I have written. Okay, we have to use those two results to solve this problem. In the place of x, you can write yx. In the place of y, you can write xy. Sir, what about other x? Just carry. What about other y? Just carry. Plus is plus. Now, here xy is nothing but y. X is just carry. Plus yx is nothing but y. Sorry, yx is nothing but x. Y is just carry. Now, sir, what is yx? Yx is nothing but x. Plus is plus. Xy is nothing but y. So final answer is x plus y. X square plus y square is x plus y under the given conditions. First option. Understood? The problem is designed on one concept. The concept is matrix multiplication is not commutative. AB not equal to BA in general. So wherever you have XY, you should not write YX. XY and YX are not equal in matrix theory. AB and BA are not equal in matrix theory. That's why whatever arrangement they have given, you have to take in that order only. Observe next problem. Let A be a 3 cross 3 matrix whose elements are Aij equal to I square minus j square. Then what is A inverse? Very simple problem. Aij equal to I square minus j square. Here matrix is 3 cross 3. So let us take 3 cross 3. A is 3 cross 3. A11, A12, A13, A21, A22, A23, A31, A32, A33, 3 cross 3. Now, every element of the matrix satisfies the condition I square minus j square. So, 1 square minus 1 square, 0. 1 square minus 2 square, minus 3. 1 square minus 3 square, minus 8. 2 square minus 1 square, 3. 2 square minus 2 square, 0. 2 square minus 3 square, minus 5. 3 square minus 1 square, 8. 3 square minus 2 square, 5. 3 square minus 3 square, 0. Matrix is 3 cross 3. All the principal diagonal elements are 0. Remaining entries are satisfying the condition Aij equal to minus Aj. Therefore, skew symmetric of odd order. Therefore, det A is 0. If det A is 0, A inverse does not exist. Okay, 4 to 5 problems are there, no problem. Observe next column. Let A, B, C, D be n cross n matrices with non-zero determinant. Non-zero determinant matlab non-singular. A, B, C, D are non-singular matrices. Then if A, B, C, D are non-singular matrices such that A, B, C, D equal to I, then B inverse is, 1 minute, observe. Simple trick we have. You need not to multiply with anything, nothing. You require B inverse in A, B, C, D equal to I from B, from matrix B. Sir, why from matrix B? The question is given on B inverse. That's why from matrix B. Just you follow counterclockwise order. Counterclockwise order. From matrix B, if you follow counterclockwise order, what is counterclockwise order? C, D, A. That is the answer. Even though you have 10 matrices are given, just you have to select counterclockwise order. That is the trick. Sir, why we have to follow counterclockwise order? Kaisa hai? I am explaining. Observe. A, B, C, D equal to I. Take inverse on both sides. If you take, because you are going to find inverse, that's why A, B, C, D whole inverse equal to I inverse. In matrix theory, PQ whole inverse is Q inverse into P inverse. So A, B, C, D whole inverse is D inverse, C inverse, B inverse, A inverse equal to I inverse is I. Okay. Now multiply this equation with the D from left. D into D inverse, C inverse, B inverse, A inverse equal to DI. D into D inverse is I. I into C inverse into B inverse into A inverse equal to D into I. D. Understood? Next, multiply with C from left. C into C inverse, B inverse, A inverse equal to CD. C into C inverse, I into B inverse into A inverse. B inverse, A inverse equal to CD. Now, multiply with A from right. B inverse, A inverse, A equal to CDA. B inverse equal to CDA. That's why I said, if you want B inverse from matrix B, follow counterclockwise order, CDA. Got the answer, na? Instead of doing all these multiplications, directly you will get the answer by taking counterclockwise order. Suppose you have here 4 matrices, that's why we have multiplied. Suppose if they have given A, B, C, D, E, F, G, H, I, J, K equal to I, then what is K inverse? Then you have to multiply 10 times, na? That's why better to follow counterclockwise order. Now, remaining problems we can discuss tomorrow. I would like to explain in which approach you have to learn. In the plus class, in this course, completely all the problems are arranged in all variations, all different varieties of problems I have selected, and I am discussing topic wise in the class in a sequence. But in the examination, you won't get the questions in sequence. That's why what I have done, in the class, I am going to discuss all varieties in a sequence. In the practice course, all different varieties are merged in zigzag manner. So directly if you go for practice course, you won't get anything. That's why first regular course, after understanding the concept, you have to learn from the practice course. After that, you have to go for PYQs. different varieties of PYQs I am solving in the classroom course here in this course. Okay. So what I said, after completion of first chapter, you learn all the concepts. After that, you watch the recorded videos of practice course. Yeah, practice course is nothing but whatever book I have given, that book only. In that book, I have given questions with key, questions with answer key. Solutions I have not given. Those solutions are available in this practice course. Okay? First regular course, then practice course, then PYQs. This is the order. If you follow this order, you can get 15 out of 15 marks. 100%. I can give the guarantee. Okay? For CSIT, only for computer science branch, you have to follow only 3 chapters. Linear algebra, calculus, probability and statistics. For the remaining branches, according to their syllabus, they have to follow all the class, all the course, right? Where is this book? The book is available in the Telegram group as well as in the WhatsApp group. Just I am giving the contact details. You just send me the message. Yeah, class is over. Today's class is over, right? Mayank, practice course is already going on in the evening 6:30 to 8. 6:30 p.m. to 8 p.m. Okay? 3 chapters I have completed. 4th chapter is started. Disha, you can message, no problem. Definitely send me the message. I will add you in the group. Okay? Shreyan, there is only one book, Objective Questions on Engineering Mathematics, right? Thank you. Good night. Tomorrow I will discuss rank of the matrix, linearly dependent and independent vectors. Toughest concept. If you understand linearly independent vectors and dependent vectors, you can understand eigenvectors, right? Thank you.